So for law of sines, again, it's used for any triangle. And the word any on this means not just a right triangle. So even if you don't have a right angle, you can use law of sines. What law of sines is it's just a three-part proportion here that you see. Sine of angle A over its corresponding side A, sine of angle B over its side B, and so on. We're only going to use two parts of it at any time, though. You're going to use either angle A and angle B, or angle B and angle C, or A and C. Okay? What you do need in order to use the law of sines, which you see on the back page here from this, is you need to have at least one side and angle pair. And what that means is you either need angle A with its side, angle B with its side, or angle C with its side. If you don't have at least one set, you can't have one piece of A, one piece of B, one piece of C. It doesn't work for a law of sines. So you need at least one angle side pair, which is what it says on the box on the back, and you need at least one other angle or side. It's very easy to solve this proportion. The math of this is not difficult at all, but it is all calculator. There's no way to do this without your calculator. So in question 1 here, I first check on any of these questions to see if I have an angle side pair. I do, so I can use law of sines. So I'm going to go ahead and set up sine of angle B, or 35 degrees, over side B. Now, out of this information, if I'm going to set up sine of angle C over here, which is 50 degrees, what piece of information am I missing or am I solving for? Side C, right? That's the whole point of this, to solve for missing parts. Remember when you have proportions, how do you solve these? Cross multiply. Quick review of cross multiplication, because it's been a while. When you cross multiply, you multiply the two opposite pieces diagonally from each other, and they are equal to each other. I see some people cross multiply and write it as a fraction. I'm not real sure where that came from, but it's not how it works. If I would then like to solve for side C, what do I divide by? Sine of 35, both sides. So in your calculator, you're going to go ahead and type in this whole thing at once. Remember, for this entire unit, as well as next quarter even, we're going to do sides to 2 decimal places and angles to the nearest degree. Now this one says to solve for all missing pieces. What is still missing after we get side C? We are still missing angle A and side A. Now, some of these will trick you because they don't always give you all of the information that you think you need. But remember, how many angles of the triangle do you currently have? 2 out of the 3. How do you find the third angle of a triangle? Subtract from 180. So even if you don't have a picture showing that, which a lot of people feel like they need to see that part, I get about 12.02 for side C. I can continue on to find angle A very quickly by just subtracting 35 and 50 from 180, which then makes it very easy with an angle A of 95 degrees to solve for side A. Again, using the law of sines. This time I want to solve for side A, so I'm definitely going to set up sine of 95 over A, the missing side. Now, you know me well enough at this point in the year to know this. If you were me, which other side and angle pair would you be using now? B. Why? It's given, and we know there's no mistakes in it. I'm always going to be safe if I can. So I set up sine of 35 over 9, and I cross multiply again. That one's going to give me a sine of 35 is equal to 9 sine of 95, and then I divide both sides by the sine of 35. Again, because we're solving for a side, I'm going to round to 2 decimal places, which gives me about 15.63. Math-wise, not real hard, right? Okay. And it's not. It's just remembering how to do it. The one thing I always want you to kind of mentally check here, remember in geometry we learned that all, like the largest angle goes across from the biggest side, the smallest angle goes across from the smallest side, and so on. If your answers do not line up with that, you have done something wrong. Please check your work. Okay, use some of your common sense. So the fact that angle A is the largest angle at 95 and side A is 15.63, that is the largest side, it should make sense numerically. Okay? Now, for those that are sitting there thinking, surely this can't be that easy, you are correct. There is a problem with the law of sines, and you will see that in question 2. I'm going to try my best to explain what the heck this is to you. It never makes sense to people the first time. There is something with the law of sines called the ambiguous case. Okay? If you know your English words well enough, ambiguous case means something that is uncertain. Okay? What it is in this case is that anytime you're in this case, there are possibly or possible 2 answers. Okay? Now, the only nice thing about the ambiguous case is that it can only happen in certain circumstances. Okay? And here are the circumstances. This only happens when you are given 2 sides and an acute angle. And with the law of sines. If you're given 2 sides and an acute angle and you can use the law of cosines, it doesn't apply. Here is why this happens. Actually, let me get to a certain point in the problem and then I'll tell you why it happens, because you'll see it better there. First off, in this problem, are we in the ambiguous case? Yeah. I'm given 2 sides and an angle that is acute. And in fact, the smaller the angle is, the more likely it is to have an ambiguous case. So the smaller it is under 90 degrees, the more likely we're going to have 2 answers. Let's just set up for the first thing here, because you set up just like normal. What angle can we find using law of sines here? Angle A. So we're going to set up sine of angle A over side A equals sine of angle C over side C. I'm going to cross multiply just like I did in the last problem. So far in your problem, nothing different. We cross multiply. I get 7 sine of A equals 10 sine of 30. There's a slight difference here in solving because we're solving for the angle. What do I need to get away from the left side in order to solve for that angle first? And divide by 7 both sides. Then, when we're solving for angles, angle A, how do I solve for that in my calculator? Or what buttons do I use? I use the inverse sign of the stuff on the right. Remember, inverse sign is used when you are solving for angles. So in my calculator, I'm going to go ahead and type in the inverse sign of 10 sine 30 over 7. Remember, with angles, we're rounding to what? The whole degree. So this one's about 46 degrees. Here's where you need to recognize that your original problem was in the ambiguous case. So while your calculator spits out 1 answer for angle A, there are actually 2 possibilities. Okay? Now I'm going to tell you why there's 2 possibilities. Remember 2 days ago? We did a problem like this. We said sine of theta is equal to 1/2. That's a good example. What did we do in order to find that angle? You drew a triangle. Okay. You could draw a triangle, but for that specific one, we looked in our chart, right? And we said, where in our chart is sine equal to 1/2? Anyone remember where that happened? In the first quadrant, it happened at what reference angle? 30 degrees. But we also said that's not my only answer, right? Because of all students take calculus, I can have 2 answers. Where else was sine positive? Over here at 150. So in those kind of problems, we had two answers, right? Here is why we have two answers here. Because you've asked your calculator, where is sine equal to this value? Your calculator tells you the one in the first quadrant, just like you found the one in the first quadrant in your chart. Your calculator will not give you the one in the second quadrant. But how did we find that one in the second quadrant? We just did 180 minus that angle that we just found. We did minus 30 because that's what we found. Well, in this case, my other possibility for angle A, I'm going to get that by subtracting this from 180. I'm going to call this one A1 and this one A2. If I subtract 46 degrees from 180, what do I get from my other possibility for angle A? 134. Now, this only happens in the law of sines because cosine is positive in the first quadrant and negative in the second, so your calculator can distinguish between the two. It can't on sine because it's positive the whole first quadrant, and your triangle angles go the whole way from 0 to 180. So this is why it happens. If it has two possibilities for angle A, it's also going to have two possibilities for angle B. You just have to see if it does happen. Because still, in both cases, you still have to be able to have a third angle, right? I still have to have room in my triangle for angle B. Sometimes you will check, and over here in the second case, you won't have enough degrees left to have an angle B. Then you just eliminate the second case, and you are done with that one. But either way, let's go through our cases here. If C was originally 30 degrees, in case 1, A is 46 degrees, how do I find B1? Okay, I just subtract 180 minus the other 2, which is 76 degrees, leaving me 104 for B. Is that okay? Yeah. Now I check the second case. If C was 30 and my A is 134, do I have room left for angle B? Yeah, that leaves me 16 degrees. Which means I have a full two sets of answers. There's two triangles that can be constructed from the information that we're given. We're missing one final piece on each one. What is it? Side B. Again, I would use the given information as much as possible. So for this one, I would set up sine of 104 over side B equals sine of angle C over side C. And I would do the same thing here using my different angle B. So in this case, you have one answer. In the other case, you have a completely different one. But both you get by cross-multiplying. Take a minute and cross-multiply in your calculators. So over on page 85, we'll talk about our second law for today, which is our law of cosines. I have a small edit for you to make on the page here. Because we do have to know our formulas, I'm trying to limit them to only the necessary ones here. Some people do law of cosines in two forms like you see here. I prefer to not do that, so just scratch this out completely. Also down here is the proof for it, which I have in my key if you're ever interested, but we're not going to talk about it in class. Law of cosines is used when you can't use sine, cosine, tangent, Pythagorean theorem because it's not a right triangle, and you can't use law of sines. Because remember, for law of sines, you needed a side angle pair. Sometimes you don't have that, and that's when we use law of cosines. There are three forms of the law of cosines, and I don't want to scare you with that because it doesn't mean you have to memorize 4 formulas, 3 cosines and 1 sine. The law of cosines all follow a pattern, okay? And so this first version that they show here in the box, notice what side is over here on the left, C. What angle is over here on the right? C. That's always going to be true, and that's why there's 3 forms. There's a form where the C is on the left and the angle C is on the right. There's a form where A is on the left and angle A is on the right. And there's a form where B is on the left and angle B is on the right, because you need to have a form for every angle. Notice also, while you're at it, if C is on the left and angle C is on the right, what letters are all in that box there? A and B. Okay? So you can guess if I wrote another version of this. For example, if I wanted one solved for A. First off, it would start with A squared and it would end with what?
C squared.
Cosine of A over here. And what letters would be in the middle? B and C. So I would replace B squared, C squared minus 2BC. Just following that same pattern using B and C. Alternately, if I wanted to have a version solve for B, it would be a B squared here. It would end with cosine of B. And what letters would be in the middle there? A and C. Following the same pattern. So I choose to memorize one version of it and just know how to replace the letters to make the other two, because that's easier to me. It's up to you. If you're better at just memorizing, you can memorize all three forms. Okay. On the back in the box is the two places that we use the law of cosines. I'll take a minute here if you need those. On the back, like I said, if you know the sides, two sides and the included angle, we always forget what that means from geometry. The included angle is the angle between the two sides, but that just means two sides that don't go with the angle. So it would be side A and B, angle C. Side B and C, angle A. So you don't have an angle side pair, or all three sides no angles. Okay? So clearly in question 1 here, if I look at that, I have no matching pieces. I have angle B, I have side A, and I have side C. Can't use law of sines, must use law of cosines. The first thing that I would love for you to show me on any law of cosines problem is what formula you're using. It's determined by the angle that you are given or the angle that you are finding. Those 3 versions. The first thing I look for here is the angle. I'm given angle B. So I must use, to start off with, this version, where it's solved for your B's. So I would love to see on your papers for a quiz or a test, especially that first. That tells me alone if you actually know the right formula and the right version of it. Then most of this is just plugging in with your calculator. They would like me to find side B, so I plug in what I know. A squared plus C squared minus 2 times A times C times the cosine of angle B. Notice what we're solving for is already by itself on the left. This makes life very, very easy for us. Please, the only thing I will actually tell you, and this is one of the few times you hear me say this, type it all in one step in your calculator. The more you try to split this up, the more people get it wrong, and I don't know why you try to split it up. Literally type this in one long row. That is it. Okay? So I'm going to type in 5 squared plus 6 squared minus 2 times 5 times 6 times cosine of 35 all at once. The one easy place to go wrong is to type a sine rather than a cosine. The other easy place to go wrong is right here. Is what my calculator spits out at me the answer? No. That's the answer for B squared. A lot of times people forget that, especially if it's a reasonable answer like the one you got here. That looks reasonable. Some people just jump to conclusions and stop. Square rooting that, however, gives me B is 3.44. That's also where I say remember the fact that the largest side and the largest angles will go together. You don't have any of the other angles. However, B is kind of a small angle at 35. So it shouldn't be a side of 11.85 that's larger than the other 2 angles. Any issues with that one? One thing, this one doesn't ask me to solve for all missing parts. It only asks me to solve for B. If it did, do I now have an angle side pair? Yes. I have angle B. I now found side B. If you had to find the other pieces, you can go back to using law of sines. So you can combine law of cosines and law of sines in the same problem. If you find sines easier to solve for the other angles, you can go back to that. This one, again, didn't ask us to, so we won't. The other version where law of cosines can be used is in question 2, where you're given all three sides and no angles. This will be our last example. We'd like to find angle A. Remember I told you the version of the formula depends on the angle you're given or the angle you're finding. Since you're finding angle A, that means I need the A squared version. Now make a note for yourself on this kind of problem. If you have a choice, solve for the largest angle first. Here is why. How many of us like the ambiguous case? 0 of us, right? Remember how I told you you could avoid it sometimes? Okay? If you start off here by solving for the largest angle, then what kind of angle are you most likely to have, an obtuse or an acute? Most likely to have an obtuse, because it's the largest one. Now, can they all be acute and still be a triangle? Yes, it's possible. But if you can save yourself from that, you can get your obtuse angle, then you don't have to worry about the ambiguous case, because you already have the biggest angle. That one's out of the way. You don't have to worry about it. Okay? So that's just kind of a good rule of thumb. Solve for that first using law of cosines, because law of cosines has no ambiguous case. So be safe. Now, in this case, how would you tell which one should be the largest angle? The largest side. So they did have us solve for the largest angle first. Let's plug in what we know. This one takes just a little bit more work to solve, but it's just algebra, so don't panic on it. The other one was super nice because it just had all the stuff on the right to plug in. This one, unfortunately, what we're solving for is all the way back here. Now, I say this every year, and every year probably a good 10 people do it still. Here's what you do not do in solving for this. Type all of these numbers in your calculator and put them in front of cosine. Please do not do that. Why not? What numbers are actually attached to the cosine?
2, 5, 6.
Okay, just these. Okay, first step in solving these is to get rid of these terms by moving them to the other side, both of them. So my first step is going to be to do 10 squared minus 5 squared minus 6 squared. That gives me 39. Second caution, do not lose that negative. What's negative 2 times 5 times 6? Negative 60. That's the number that goes in front of the cosine. If you lose that negative, what will happen is sometimes your calculator won't be able to find the angle for you. So someone will walk up to me and say, why is my calculator giving me an error? Because you've done something wrong. Okay? You've gone horribly wrong here. All right, so now, how do I get the cosine A by itself? Divide by negative 60. I'm going to leave this in fraction form because how do I find an angle in my calculator? Okay, I put in the fraction using the inverse what? Cosine. This is going to give me the angle. Okay, does that take a little bit more algebra? Yes, it does. Is it really that hard? No. So in my calculator, I'm doing inverse cosine of negative 39 over 60. This would be a great one where once you have this angle, which is about 131 degrees, you did get the obtuse angle, which means you really don't have to worry about the ambiguous case. You could totally just keep going to get the other two angles with law of sines. Okay? Or one of them and then subtract from 180. But you don't have to here. Okay? So 2 parts to your homework. Homework begins on page 77. That's where the bulk of it's going to be. Page 77, you are going to do 1 through 9. While we are there, I'm going to flip there real quick. Remember, this is law of sines. This is where you could have the ambiguous case. Quick review. Ambiguous case only happens when what? You're given 2 sides and an acute angle. Take a look at this first page. I'm on page 77. How many of those on 77 are even eligible for the ambiguous case? None. Why? 2 angles. Flip to the back. And careful before you yell your answer on this one. How many of these are eligible? 2. Which ones?
5 and 7.
5 and 7. Make yourself a little star next to 5 and 7. Those are the only 2 you have to even check for the ambiguous case. Now, it seems stupid that I just went through and said that. That is how I want you to approach a quiz or a test with these as well. Scan the whole thing first. See which ones you'd have to use the ambiguous case on and mark them. Therefore, then you will not forget them. The other part to your homework is on page 89, and it is just 1, 2, and 3. Okay? 89, 1, 2, and 3 is the last part.